Hey, what's up, guys? LeetCode number 2009, minimum number of operations to make array continuous. Okay, uh, interesting problem. So you're given like integer of arrays, nums, right? And in one operation, you can basically replace any element in the numbers to any integers. Okay, and then we define number is considered continuous if both of the following conditions are met. Okay, so first, all the elements in nums are unique, and then the difference between the maximum and the minimum equals to this nums, the length minus 1. So what does this one mean? It means that, so apparently, right, so a number is continuous. If it's sorted, it's going to be like two, let's say 2, 3, 4, 5, 6. This one is continuous because the length will be, so 6 minus 2 minus sorry, 2, 3, 4, 5, 6. So the difference of this one will be the 6 minus 2 equals to 4, right? And this 4 equals to the length. Length is 5 minus 1. So which means that, from the start and end, so we have each number in between. There's no gap, right? And then, but the order doesn't really matter. Basically, this one is like considered to be continuous, and this one is also, right? So which means that, it's going to be a permutation of this continuous numbers in any way, right? So our task is to find what are the minimum numbers of operations we need to make these numbers continuous, right? So for example, like this one is already continuous because it's already a permutation of 2, 3, 4, and 5, right? That's why this one is 0. But for this one, it's what? For this one, the number is 1 because we. So one way of doing this is we can change the 6 to 4, right? In that way, we only need one operation. Another way is that Another way is that we can change this 1 to 4, right? In this way, it's going to be a 2, 3, 4, 5, 6. This is another like optimal solution, right? And then here, this one we have what? We have the answer will be 3 because we need to change like this 10 to 2, 11, 100 to 3, and this 1000 to 4, right? Or we can do this 10, 11, 13, and 12 and 13, right? So this is another way of doing this, but the answer will be the same, okay? And some standard constraints, right? I mean, so this one actually, it's kind of straightforward, right? Basically, so first we want to sort this array, right? Because we know if we sort it, right? If we sort this array, then it's easier for us to find out which way, like what are the numbers we need to change, right? And how can we find like how many numbers we need to change, right? So what we can do is that we can assume like we start at any number, right? Because and why we need to try to start with any numbers is that the reason we cannot only assume we start from the first number is because let's say we have a 1, right? And then we have 20, 21, 22, and 23, right? So apparently with these 5 numbers, the best way of doing this is what? We need to start from 20, right? Which means we need to change 1 to 24, right? So this is the optimal solution, right? If we start from 1, right? So if let's say we fix the starting point, right? We fix start. Oh, and one more thing is that it's I think the answer always in among the cases where we'll start from any of the numbers. Apparently, that will be the answer will has to be one of those scenarios, right? So like I said, if we start from 1 in this case, we know, okay, so because once we fix the starting point, and then and since we already know, we also know the length of the array, then we can easily get the last number. If we start from this one, in this case, it's going to be what? The last number will be 1, 2, 3, 4. It's going to be 5, right? And then with 1 and 5, then we know, okay, we can know what are like how many numbers we need to change so that we can fit all the numbers within into this 1 to 5 range, right? But like you guys, as you guys can see, if we start from 1, we have 1 and 5, right? And then how many numbers we need to change to fill in? We need it's going to be 4, right? Which means we need to change all 4 numbers to fit into this 1 to 5. Okay, right? That's why the best answer will be starting from 20. That's why, like I said, we need to try each of the number as a starting point. And then as to how can we quickly find the numbers that we need to fit into this range, we can use a binary search. Okay, so this is because let's say we have a okay. So let's say we're trying to do a start from this I here, right? And then we know, let's say this is 3, right? And let's say we have the last number will be, we have 1 2 3 1 2 3 4 5 6 and 7, right? So 3 plus 7 is gonna gonna be 10, right? So 1 2 3 4 4 5 4 5 6 7 8 9 10. So the last number will be 10 in this case. So let's say the 10, and we have 10 here, right? Okay, so we have 3 and we have 10, and we have this kind of numbers, bunch of numbers here, and this one is 3, right? How can we find out how many numbers we need to change in order to fit in all the numbers inside this 3 to 10 range, right? So what we can do is that we can do a binary search of this 10. Okay, let's say we do a binary search 10, so we have 10 is pointing to here. That means that, okay, between this I and index here, so for those numbers, we have 1 2 3 4, right? So for those 4 numbers, they are already within the range of 3 to 10, which means those numbers are the ones we don't need to change. And in the other, and which means that all the other numbers outside of this index range will be the numbers that we need to change to move to this one, right? So I think that's it. And the last thing is that when we do the binary search, right, we want to do a binary search. We want to do a bisect right instead of bisect left. So the reason being is that, let's say we have, so let's say if this number is 10, it's 10 itself, and the last number is also 10, right? So which means this 10 needs to be included into this range because 10 is one of the answer, right? That's why we need to, so the index in this case need to pointing to here. It's going to be the index. It means that between I and index are numbers we don't need to change. Okay, if we do a bisect left, then this 10 will be excluded into this range, which is wrong, right? And okay, so the last thing is that even though it didn't give you this example here, we could have duplicate numbers, right? Basically, after sortings, we need to remove the duplication. And the reason being is that let's say we have 2 3s, right? So let's say we have this kind of let's say this number is also 3, right? So if we don't remove the duplications, right? And so what we'll have, well, basically, as you guys can see, we have, so basically the same 3 will have different index here. So this one will have I, then this one will have I plus 1, right? And both of them will have the same like binary index here, and basically the same number will give us different answer in the end. That's why we need to remove the duplication. Yeah, I think that's it. Let's start coding. So the coding is pretty short, basically. We need the length of nums. This is the original. Basically, this is the target length, right? And then we have numbers of we can remove duplications by this, right? Along with while we're sorting it. Basically, we convert into set to remove the duplication, and then we do a sorting, right? And then we have the answer equals to system dot max size, and then we have for I and the number, right? Enumerate of numbers, right? So the end, we already know the end of the number. So the last number will be the what? The number plus n minus 1, right? So basically this will be the start actually. So let me do a s and n. So it's going to be at start. Start plus n minus 1 will be the last number, right? And then we do a binary search on this numbers. It's going to be a bisect right of numbers, right, of e. So now the range will be from I to index, right? From I to index, actually minus 1, right, will be the numbers don't need to change, right? So which means any number that's outside of this range needs to be changed to fit in this range, and that will be the what? Will be the minimum of answer that n minus, right, of what? Index minus I, right? And then we return the answer, because the index minus I will be the length that we don't need to change, right? And then if we do a n minus this one, then we get the length, basically the length or the numbers that we need to change, right? And that's why we just get this number, and we from all this kind of possible ranges, right? And we get the minimum, and I think that's it. So this one, the more I think about it, it's more like a sliding window, right? Basically, we have a bunch of like numbers. Let's say we start from here, right? So we start from here, and then it's gonna be the end will be somewhere here, right? Or we start from here, the end will be somewhere there, and then start from here, the end could be here. And among all this kind of sliding windows, we'll get the longest sliding window, right? Yeah, I think you can also use sliding window to solve this one. But at least that's how I solve it, right? Binary search. Okay, let's try to run this. Okay, this one. Yeah, right. So that's it. Yeah, I think this one, nothing too fancy. I think you just need to realize that you need to sort this one, right, first. And then the next thing is that you have to try to fix each of the starting point of the final result, right? And then among all those kind of possible scenarios, you need to use a binary search to quickly find the range, right? And then you can get the answer from that range. Yeah, I think that's it. Thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.